Alright, for example 6, we want to use positive rational exponents if necessary, and there's even a little reminder that those can be fractions. They can also be integers. So I'll put a little integer notice up there. And do not use negative exponents or radical notation. So keep in mind we don't want to see any of those guys. Alright, if we look at the left example here, A, we've got an exponent that belongs only to this base, and then an exponent that belongs only to this base. What we want to do first is go ahead and take care of our power of a power rules. And so the 1/8 is going to be multiplied by the 6, so that's going to be 6 over 8, y to the 4 over 8 power, and then plus 2. The 2 does not get squared. It is outside the parentheses and it's by itself, just leave it. Inside the parentheses though, we should have x to the 2 over 3 and then y to the 2 over 4 if we take this 2 and multiply it by each one of these fractions. Let's see what happens when we simplify these fractions. So on the left hand side we've got 6 over 8, which is 3 over 4, y to the 4 over 8, which is 1/2, plus 2, nothing going on outside the parentheses so we can lose them. X to the 2/3 and then y to the 1/2. Now this is kind of a tricky question because to be able to add these two together, we need to have all the variables being raised to the same power. If we look at the y's, we're totally good on the y's, but we need to have also the x to be raised to the same power, and that is not the case. So an often made student mistake is to try to go ahead and either add these two together or apply your multiplying like bases rule. So some students will try to take this y and this 1/2 and add it to the 1/2 because they see a plus sign here. This has to be a multiplication sign. It is a plus sign, and we can't actually add these terms together because this term is not like this term. Yeah, there's a y to the 1/2, but the x to the 2/3 needs to be exactly the same as the x to the 3 over 4. So unfortunately, at this stage of the game, we're kind of done, and this is the best that we really can do. Now, if you wanted to, you could factor out like a y to the 1/2. So, you know, if you had to, you could make this y to the 1/2, then in parentheses, x to the 3 over 4 plus 2x to the 2/3. That would be a possibility, but we really don't have to do that here. We're using positive rational exponents. Do not use negative exponents or radical notation. Okay, there's no negative exponents, there's no radical signs, so we're good here. On part B, there's a lot going on. We really can't do anything with these fractional exponents right here, but we do need to make sure that we take that -2 and raise that to the 1 power and multiply that by a 4 here. So your exponent rules would state that you need to take this -2, multiply it by the 1, excuse me, by 4. Never multiply -2 by an exponent. Never multiply a base by an exponent. So multiply that 4 by that 1. That's a 4. Then we've got x to the 4 over 3 all over, then y to the 4 over 2, and z to the 4 over 6. The only thing left to do is to go ahead and do this math part right here, -2 to the 4th power. It's negative times negative times negative times negative, which is totally positive, and 2 to the 4th power is 16. X to the 4 over 3, can't really do anything with that. That's all good to go. 4 divided by 2 though, that's 2, so it's going to be y squared. And then z, 4 over 6, is just 2/3. Don't want to use any roots or any radical notation here. It says don't use that. And it says don't use negative exponents. You should only use positive rational exponents. And that's what we have here. We just have some positive rational exponents. So that's your final answer.